So first, let's look at two examples of expressions that we might need to put together and have like denominators, right? We've talked about to add or subtract fractions, the denominators have to be exactly the same. Okay, so let's look at these two and see if we can get them exactly the same. First thing we're going to do is we're going to look at the first one and factor out a 2. So that leaves me with x squared minus 4x plus 4. Okay. Now, let's factor x squared minus 4x plus 4. And we get 2 times x minus 2 times x plus 2. Right? That's as far as we can go. Okay, let's do the next one. What can I take out of 15x squared minus 60?
No, it would be x minus 2 squared.
Yeah, because if you x minus 2 and x plus
Oh, you're right. They're both negative. You're right. 2 negatives. Okay, so the next one I'm going to take out 15, and I'm left with x squared minus 4, and that's a difference of 2 squares. So that answer is going to be x minus 2 and x plus 2, correct? Okay, how are these different? What do we need to add to them to get them to be the same? This has 2 x minus 2's, and this has only 1. So that means we're going to have to multiply this by x minus 2. This has an x plus 2 in it, so that means we're going to have to multiply this side by a x plus 2. This has 15, where this has 2, so what do I need to multiply them by? What's the lowest common multiple that 2 and 15 can go into? 30. So I'm going to have to multiply this side by 15. I'm going to have to multiply this side by 2. So we're going to end up with 30 times x minus 2 times x minus 2 times x plus 2 for both sides. Questions?
Can for the 2x minus 2, can you just put x minus 2 squared?
No, because it would be x squared minus 4x plus 4.
Oh.
Okay. All right. Let's look at number 2. Now we have 2 fractions. We have to get them to add it together. So we need the denominator to be exactly the same. We can't change 1 at all, so I'm just going to bring the 1 over. All right. The first thing I'm going to do with this expression right here is to pull out a 3. And I'm left with x squared plus 7x plus 10, correct? Okay. So I can do a 3. What am I going to do to this? What's going to add, multiply together give me 10, but add together give me 7? X plus 2 and x plus 5. You gotta wait till. Okay, I'm gonna leave 4x on the top. What can I pull out of 3x plus 15? 3. So I'm left with x plus 5. Okay. What do I need to multiply one of them by to get them to be the same denominator? X plus 2. And remember, whatever we do to the top, to the bottom, we've got to do to the top. Okay? So let's rewrite this. We have 1 over 3 times x plus 2 times x plus 5 plus 4x times x plus 2 over 3 times x plus 5 times x plus 2. Okay? Now we're going to add the tops together. We're going to get 1 plus 4x times x plus 2 over, and the bottom stays exactly the same, 3 times x plus 2 times x plus 5. Okay? The next step is we are going to just distribute that 4x to see if I'm going to get something that's factorable so I can cancel something out. So I'm going to distribute the 4x. And I'm going to end up with 4x squared plus 8x plus 1 all over 3 times x plus 2 times x plus 5. Okay. Is 4x squared plus 8x plus 1 factorable? No. So I'm done here. This is it. All right, let's look at the next one. Number 3. Can I change the top at all? Is that factorable at all? No, so I'm just going to leave it as 2x. What about the bottom? What am I going to get? X minus 3 and x plus 1. Minus 3, because we can't change the top. What can I take out of 4x plus 4? 4 times x plus 1. So what do I have to do to them to make them have the same denominator? You have to multiply this one by x minus 3, the top and the bottom. And you have to multiply the top and bottom of the other one by 4. Okay. So I'm going to end up with 8x over 4 times x minus 3 times x plus 1 minus 3 times x minus 3 over 4 times x plus 1 times x minus 3. And then I'm going to subtract. It's going to give me 8x minus 3 times x minus 3 over 4 times x minus 3 times x plus 1. Next, I am going to distribute my negative 3 and combine like terms to see if I can simplify it. So I get 8x minus 3x plus 9 over 4 times x minus 3 times x plus 1. And then 8x plus 3x gives me 5x plus 9 over 4 times x minus 3 times x plus 1. And there's nothing I can do to factor the top, so that's as far as I can go. Yes?
So you don't, like, since you had x minus 3, x plus 3, x plus 9, you don't cancel those out.
Nope, you can't, because it would have to be in both. Because there's that subtraction sign in the middle of there would have to be an x minus 3 in both of them in order to cancel it out. Any other questions about this before we move on? Okay, for your homework, sometimes you're going to be adding or subtracting 3 or 4 things together. Okay? You just make sure that they're the same. We are going to practice multiplication and division. We're going to practice 2 division problems one more time. But don't get thrown off by the fact that there's 3 things here. You're just going to make all the denominators the same and then put them together. Okay, for your classwork and your homework. We're going to do 2 more problems and then we're done, guys. Okay, we're going to do division. It's just another practice. Remember, division means we flip these 2. So I'm left with 7x over 2 times x minus 5, right? Because I pulled out a 2. And we're going to times that by these. So what is x squared minus 11x plus 30 factored out to be? X minus 5 and x minus 6. And the bottom, we can take out an x, so we left with x times x minus 6. Cancel these, cancel these. So we're left, and we can cancel the x's. So we're just left with 7 over 2. What can x not be, guys? Yep. 6, 5, and one other. That x is all by itself, so it can't be 0. All right. I'm not going to do the last one. I'm going to let you guys do your homework to get started. Then you've got classwork and homework to do. Remember, tomorrow we're reviewing, and Friday we have the quiz on this stuff.